Hey lads, sorry I couldn't make class. I'm gone to a match today. But I do feel it's vital to get through this standard deviation, which is why I've made this video, and hopefully we can push on through this. If we've got any questions on it, you can ask me when I get back tomorrow, okay? So you're probably thinking, God jeez, he's gone and yet he's still here. We can't get rid of him, but I guess that's just the way it is. But we're going to look at standard deviation. We're going to go back over what we did before the weekend, and we're going to push on then, because I felt the last day was a bit rushed. The bell kind of caught up with us. So your homework, lads, page 101, questions 1, 11 and 15. That's just basic standard deviation, so you shouldn't have a problem with that. Page 102, question 18, that's to do with the empirical rule. Have a look at page 100. It's not a hard question, just spend 5 minutes looking over it and thinking about it. Once you get it, it's very easy after that. And page 104, question 1 then. That's standard deviation using frequency distribution table, okay? So I'll give you 2 minutes to take that down, lads, okay? Right, so we're going to look over standard deviation. We did this in class the last day, but again the bell caught up with us. So we're just going to quickly go over it here. So we have symbols used to show our standard deviation formula. It's just shorthand notes. So I'm going to go through the actual formula, and then I'm going to go through a simplified English formula for you. So here we've sigma, which stands for standard deviation. We have this, which stands for the sum of, n, which stands for the number of numbers, x, which is the number we're going to talk about, and u, well, I actually don't know what this is yet. It's a letter of the Greek alphabet, which I'll find out for you. Okay, so anyway, I'll find out about that for you the next day. But it stands for the mean here, and this is the most important bit of all. This stands for the number minus the mean. Okay, so this is very important. So if we look at formula for standard deviation equals the square root of everything, the sum of the number minus the mean squared. Okay, and remember we were talking about that? All the square root and the square inside does is it makes the number in here positive. If it's a negative number, it makes it positive. And underneath, the number of numbers. So the simplified formula, standard deviation, is the square root of all the numbers minus the mean squared over the number of numbers, okay? Here's an example of a standard deviation question. Here's our formula. We're going to need to know what each of these mean. Okay, so again, the sum of the number minus the mean squared all over n, the square root of. Find the standard deviation of the following: 2, 5, 6, 10 and 12. So find the standard deviation of this group of numbers. Step 1, first thing we have to do is find the mean. Now the mean, as you know at this stage, is you add up all the numbers and divide by the number of numbers. So let's do that. 2 plus 5 plus 6 plus 10 plus 12 all over the number of numbers. 1, 2, 3, 4, 5. We add up these, so 2 and 5, 7 and 6, 13, 23, 35 all over 5, which gives us 7. Great, so we have a mean, or as we'll let it donate as this symbol here, equals 7. So we have our mean, okay, fair enough. So I'm just going to write it up here. The mean is 7. So the next thing we're going to have to do, we're going to have to find this bit here, the number minus the mean to be squared. So here we go. Let's take 2 first. So in our first I suppose step, 2 is the number. So 2 minus our mean, which is 7, gives us minus 5. And we're going to square that, which gives us 25. Let's take our next number. 5 is our number now. So 5 minus 7 equals minus 2 squared. That's the reason we're squaring it. And we get 4. Next number, 6. 6 minus 7 equals minus 1 squared. And that gives us 1. 10 minus 7 equals 3 squared, which gives us 9. And the last one, 12 is our number. Minus 7 equals 5 squared, which gives us 25. Now we slot it into our formula. So just look for a bit of space on my board. Okay, so we go back up here. Again, you'll have more space than I will, so you can just lay it out all under each other. But here we go. Square root of the sum of, well, we're already, if we add up these, that is the sum of. So we'll say 25 plus 4 plus 1 plus 9 plus 25 all over the number of numbers 1, 2, 3, 4, 5 equals, let's keep going, square root of, let's add up these. So we have 25 plus 4 plus 1 plus 9 plus 25 equals 64. So it's 64 over 5. Okay, again I'll go down here, sorry about this now. Equals the square root of 64 divided by 5. So we divide it by 5 equals 12.8 and get the square root of 12.8. And that gives us 3.57. So 3.57 is our standard deviation. Okay? If you want to take that down as an example, I'll give you a few minutes to do that. Okay? So now we're going to look at empirical rule. Empirical rule provides estimates for large populations. It's only estimates, and it's only a school of thought as well. But I suppose it's a school of thought that a lot of people agree with. It states 68%, and this is a set percentage, it is 68% of the sample is within one standard deviation of the mean. It'll make more sense when we come down here. And again, just using the mathematical terms, 68%, one standard deviation of the mean is set like that. So here's the mean, standard deviation, so it's within, so it's plus or minus one standard deviation. 95% of the sample is within two standard deviations. So if you look at here, here's the mean, within, plus or minus, two standard deviations. And almost all, around 99.7ish%, are within three standard deviations. So if you were to write it in mathematical terms, it would be standard deviation plus minus 3. Mean plus minus 3 standard deviations. Okay, so let's have a look at this. This is called a bell curve. Now it's always symmetrical. So we're told that the mean is 350. So that means the average or the mean amount of points that people got, and this is about CAO, okay, so the points for the leaving cert. So the mean points, so the average amount of points that people in the CAO got last year was 350 points. They worked out the standard deviation and it was 80. So if you look here, the median, which is the average of what everyone got, is in the middle, and it's 350 points. Now, the way the bell curve is shaped, our standard deviation is 80. So if we go one standard deviation either side of this, from here to here, from here to here, one standard deviation, which is 80. So if we go 80 either side of our mean, we should catch 68% of the overall population. Okay, so what this is telling us is 68% of the overall population got between 430, which is 80 above the mean, and 270, which is 80 below the mean. So this bit here, all this, okay, so from here to here, got 68% of the sample. It's caught in there, 68%, and here. So if you look, that's one standard deviation. The standard deviation is 80, and we went one either side. So 180 that side of the mean, 180 this side. Drop it down, 270, 430. So that means 68% of our population is in here. It says 95% is within two standard deviations. Well, one standard deviation is 80, so two standard deviations is 160. So if we went 160 either side of our mean, 160 this way, 160 that way. Well, if we went 160 up from 350, we get 510, which is here. If we went 160 back the way, below 350, we get 190. And what that is telling us is 95% of the people in the CAO that did their leaving cert got between 190 and 510. If we went, okay, the third step, if we went 3 standard deviations, we should be after getting nearly everybody. So let's go 3 standard deviations. Well, one standard deviation gets us up 80 to 130, or back the way gets us to 270. 2 standard deviations gets us up to 510, 80 and 80, 160, 160 added to 350 is 510. So up the way it gets us to 510, back the way it gets us to 190. So again, as we said already, 95% of the people got between 190 and 510. Let's go 3 standard deviations. So from here up another 80, so it'll be 80 to 430, another 80 to 510, and another 80 will get us to 590. 510 plus 80, which is our standard deviation, will get us to 590. And if we go back the way, it'll get us to 110. So what that is saying, almost everybody, or 99.7% to be, I suppose, more precise, got between 110 points and 190. There's always going to be a little bit outside that. Some people got 600 points, some people got less than 110 points, and that accounts for the 0.3% that we're missing here. Okay? If you want to look at page 110, take your time over, have a look. There's a question on it for homework, so again, after looking at that, it shouldn't be too hard to figure out. Okay? Okay guys, very last thing we're going to do, we're going to find the standard deviation of a frequency table. Probably the hardest of the 3. But once we memorize this formula, and once we know what these mathematical symbols stand for, and once we follow the steps, there'll be no problem. The best way for me to teach this one, I think, is go through a sample question. Again, we'll follow the steps. The great thing about this frequency table, and indeed all the standard deviation work in the mean, is that even though it's project maths, it still doesn't change a hell of a lot. If we follow the steps, we'll be fine. So, the question we're asked, find the standard deviation of, and we have a frequency table here. We have the value 1, 2, 3, 4, 5 and the frequency 2, 3, 5, 3, 2. Now let's just take an example of a diver, okay? So they're, you know, the show diving, so in the Olympics. So they dive off a platform and they can score between 1 and 5. So in this, 2 people scored a value of 1 for their dive. Okay, so the frequency, so 2 people scored a value of 1. 3 people scored a value of 2. 5 people, so again, the frequency is 5 times 5 people scored a value of 3. 3 people scored a value of 4, and 2 people scored a value of 5. In all of these, our step 1, just like the last one, is get our mean. Okay? Very first step, always get our mean. How do we do it? We did the last time. Shouldn't be any problem to you. It's the frequency multiplied by the value plus the frequency multiplied by the value plus the frequency multiplied by the value plus, yeah, you guessed it, the frequency multiplied by the value, and funnily enough, the frequency multiplied by the value, all over the sum of all the frequencies. 2, 3, 5, 3 and 2. I could write them all out, but let's just save space here. So 2 and 3 is 5 and 5 is 10 and 3 is 13 and 2 is 15. And if we work that out, we should get, okay, I'll do it here and then I'll rub it off to save space. So we have 2 plus 6 plus 15 plus 12 plus 10 all over 15, which equals 2 and 6 is 8, and 15 is 23, 35, 45 over 15, which, nice round number, 3. So our mean is 3. Okay, so just to save space, I'm going to get rid of that, but you do know our step 1, find the mean, and in this case our mean is 3. So I'll just write that up, I won't forget. Mean equals 3. Okay, our next step now, and this goes for all the questions you do if you're asked to find the standard deviation of a frequency table. You're going to draw a table of your own, okay? It's going to have 5 columns. One, two, three, four, 5. And you're going to have to learn this off by heart, okay? What goes on the top row of each column, okay? There's no simple way about it, you just have to learn it. So here we go. F, which stands for the frequency. X, which stands for the value. We've seen this before. The value minus the mean. The value minus the mean squared. The very last one. Squared. The frequency multiplied by basically this number, which is the value minus the mean squared. Okay. So let's do it for this. Well, our frequencies are going to be 2, 3, 5, 3, and 2. Okay. Our x's are going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we're walking along in rows now, so I suppose it's better off if I, just to keep it some way neat. So anyway, we finished off with our frequencies, we slotted them in, our values, which is x, okay, our numbers as I was calling them, we slotted them in. Now, our number minus the mean, okay, number minus the mean. So, okay, we can do it in our head or we can do it on the, actually write it out, we'll do it in our head. So, 1 minus the mean, which is 3, which is minus 2. 2 minus the mean, which is 3, which is minus 1. 3 minus 3, 0. 4 minus 3, which is 1. And 5 minus 3, which is 2. If we look on the next one, we square those numbers. So, the reason we squared, again, is to get rid of these minuses. We don't want them. Okay? So we get rid of all the minuses. We'll reverse that square up here with our square roots. Okay, just something for you to note. But here we go. So, minus 2 squared, which is 4. Yeah, if you don't believe me, check the calculator. Minus 1 squared is 1. 0 squared is just 0. 1 squared, again, is 1. And 2 squared is 4. Okay? Now, the very last thing with our grid. We multiply f, so here we have it, f, multiplied by our number minus our mean squared. Well, we already have our number minus our mean squared here. This is why we do the grid, okay? It stops a big mess. In the last one where we were just getting the mean of a set of numbers, there was no need for the grid. However, there's so much going on here, make sure you draw out your grid. So anyway, our f multiplied by our x minus mean squared. We have this, so we just multiply the two. F multiplied by our x minus our mean squared. Okay. So 2 multiplied by 4 is 8, 3 multiplied by 1 is 3, 5 multiplied by 0, 0, 3 multiplied by 1, 3, and 2 multiplied by 4, 8. So now our grid is done. Look back up at our formula. We want the sum of all the f's. Well, sum of all the f's, let's just add them up. Yeah? This is the sum of all the f's. So, we have sum of all the f's is 2 and 3 is 5, and 5 is 10, and 3 and 2, which is 15, which we actually got already when we were calculating the mean. So, we have this. And up top we want the sum of all the f, which is the frequencies, multiplied by x minus the mean squared. Well, we have f multiplied by the x minus the mean squared, so the sum of the e is just when we add them all up. So 8 and 8 is 16, and 3 and 3 is 6, so am I correct, 22? And that is our f, x minus our mean squared. Okay, a little bit messy there. Right, so again, running out of space, but if I can just use this bit here, because there's not much left to this. The square root of the sum of f in brackets x minus the mean squared. We have that. It's 22. Sum of the frequencies. We have that. 15. 22 divided by 15. 1.46. So we have the square root of 1.46, and just to finish it off, square root of 1.46 equals 1.20. Okay, so basically our answer is, our standard deviation of this is 1.20. Okay, so that's that. I'm going to give you a few questions now to work on. You don't have to finish them, okay, but I'd like you just to get a bit of practice now before you go home and do your homework. Okay, very last thing, lads. You want a practice question? Okay, I'm not sure how long you've left in class now after looking at that, but the practice question, page 105, question 4. you'll need to use your mid-interval values. Okay, use your mid-interval values and then do it the exact same as we did the very last question. Okay, and did you know, okay, I'll try to give you something interesting every now and again, 400 quarter pounder hamburgers can be made from one cow. Okay, so